Our assignment states the following. Before anything else, let's define the probability of a single girl and its complement. Since we don't have any numbers for it, let's use the letter G. Here, we are defining the probability of being a girl as G, and the probability of not being a girl as 1 minus G. Let's see what the question asks for. It wants the probability that all of their children are girls. Given that at least one of them is a girl, let's call the set where all children are girls as Xn, and the set where at least one of them is a girl as X. According to Bayes' theorem, we have the following. Now, let's model a Venn diagram. The whole diagram, which is the sample space, S, represents the set of all possible outcomes for n children. Each child can be either a girl or not a girl. The set, X, represents the set of all possible outcomes where at least one of the n children is a girl. The set, XC, represents the set of all possible outcomes where n children are not girls. And the set, XN, represents the set of all possible outcomes where all n children are girls. Now, let's take another look at what the question asks for. Since Xn is a subset of X, the probability of X given Xn is equal to 1. Thanks to that, we can write the following. Now, we need to find the probability of X and Xn. Let's start with X. Note that X and Xc are partitions of the diagram. This means that the sample space is the union of these sets with no intersection. The probability of X can be calculated as 1 minus the probability of Xc. Xc only has outcomes where none of the n children are girls. Note that Xc has only one outcome, the one where each child is not a girl. Hence, the probability of Xc is the probability of that outcome. Considering that the probability of each child's gender is independent of each other, the probability of an outcome with n not girls is simply the probability of not being a girl to the power of n. Note that we already defined the probability of not being a girl. With that, we have the probability of X. Let's update our main equation. Now, let's find the probability of Xn. Xn only has outcomes where all n children are girls. Note that Xn has only one outcome, the one where each child is a girl. Hence, the probability of Xn is the probability of that outcome. Considering that the probability of each child's gender is independent of each other, the probability of an outcome with n girls is simply the probability of a girl to the power of n. Note that we already defined the probability of being a girl. Let's update our main equation. There we have it.